Okay, so starting from the pressure, and just like the May June 23, the syllabus was slightly changed, and many detailed topic was reduced from your syllabus. Just like from the pressure section, now you left out with these topics, right? In previous topics, Walaikum Assalam. In previous topic, there is a concept of manometer, barometer in very detail, the concept of hydraulic lift, hydraulic brakes. So those topics were excluded. Now you can see in your syllabus, there is no topic related to hydraulic brakes, hydraulic lift is included, right? So that's why this chapter is now very concise as compared to the previous pattern. So you need to follow the new pattern. In your new pattern, these are your latest topic, right? So that's why I choose this topic first as compared to work energy power, because work energy power is a little bit lengthy as compared to this one, because that is more theoretical, right? So we are talking about the forces, so that's why we start with the pressure first. So today we are going to talk about the pressure concept, and there are some diagrams already on the screen to show the difference between the pressure and difference between the applications of our daily life. So let's suppose if we talk about the pressure, so pressure is also related with the force, right? Normally we talk about the forces, we are trying to push any object, we are trying to pull any object, but we didn't discuss that if we apply force on a specific part, right? Let's suppose if we try to just press the thumb pin, just like this diagram, the diagram number one, when we try to just apply force on this thumb pin, so there is a specific area where we are applying force. Like our thumb is in contact at specific area, right? Not on completely on complete thumb pin, right? Same goes with the box. If we are trying to push any box, so we are not applying the force on the complete box. We are just applying force on a specific area, right? So by using that concept of a specific area, we are going to drive a new relation for pressure. So actually, what is the pressure? So simply we can define pressure as force acting per unit area. So very simple concept for pressure. So the force acting per unit area is known as pressure. Per unit area, is it per unit surface area? Yes, actually that is per unit surface area. And you just used to write the area because we are not talking about area in very much detail. So that's why you just used to write force per unit area. Very simple, right? Because now we are not going to discuss about hydraulic brake, all the thing. So your topic is already very simplified as compared to the previous syllabus pattern. So force acting per unit area, and if you want to write the formula, so now formula is not a very big deal. Pressure is equals to F
Force over
over
area.
A. Yes.
Yeah.
And the symbol for pressure is P. So this is the basic formula. This is the basic definition of pressure. Now, if we want to write the SI unit, so for SI unit, there is a different concept. Like if we want to write a journal is SI unit, so you all know that we can easily derive SI unit with the help of individual quantities, right? Let's suppose if we want to write the SI unit of force. So what is the SI unit of force? Newton,
Newton's captain
right? Yes, you all know. And if we talk about the SI unit of area,
centimeter square,
centimeter square, or normally we take SI unit as meter. So
meter square.
area will be meter square. So if you don't know about the SI unit, so you can simply derive from your formula. So your SI unit will be equal to Newton per meter square. Or you may also write like this, Newton dash meter square, both are acceptable, right? But there is a law related to the pressure. We will also discuss that law. That law is not included in your syllabus, but I will give a reference of that law. It is related to liquid. So I'm not going to explain that law right now. We will discuss the reference of that law with the concept of pressure in liquid. So according to that law, the name of that scientist is Pascal, right? So that's why we use the SI unit for pressure as pascals, right? So in our exams and in our chapter, we are going to use the SI unit as Pascal, because SI unit mostly like to be named on the name of the scientist who discovered or who designed or who just give any law or any specific formula, right? We are going to write the SI unit in our theory like PA, the Pascals, right? Any confusion?
No, sir.
Okay, but we know that on the groundwork, we know that it is equals to Newton per meter square, but for simplicity, we just write Pascals because this is only for representing the pressure. Okay, now two more important thing. Let's suppose if someone asks you to increase the pressure. So you guys know that if we apply a greater force, so pressure will be greater, right? And what about the second factor? The second factor is the cross-sectional or simple area. So we can say that pressure is proportional to the area, sorry, force. We can easily identify from the equation. Pressure is directly proportional to the force means if we increase the amount of force, so your pressure will automatically increase. That is the meaning of directly, right? And let's suppose if we talk about the area, pressure is inversely to the area, right? Means that if we increase the surface area, let's suppose, so your pressure will decrease and vice versa. Okay, if we decrease the area, so pressure will increase. If we increase the area, pressure will decrease. How it will happens? In the first diagram, you can see that we just applying a force on the thumbpin. So there is a contact area with the thumbpin. So we are applying just force on this contact area with the, right? Of the thumbpin is free. There is no force applying on that specific area. Okay. And further, if we talk about the thumbpin only, so thumbpin is actually applying force on the board. You can see the area for the point of the thumbpin is very much small, right? In your daily life, you observe the thumbpin. So that area is in very micrometers or micro centimeters. Okay. Okay. So we are talking about that thumbpin. So you can see that the area of this thumbpin is very much micro, right? Because we are going to penetrate that thumbpin into the board. So the area of that point of thumbpin is very much micro, right? So it means that when you decrease your area, so your pressure will automatically increase. It means that you are not going to apply a much force or very greater force on thumbpin to penetrate that pin into the board. That's why we use thumbpin to use that papers and the charts into the board with the help of thumbpin, right? Because it is very easy to fix that paper or any chart on the board with the help of thumbpin, because we are going to apply very less effort on the pin to penetrate into the board. Okay, any confusion?
No, sir.
No, sir.
Okay, now if we consider some more examples, like the example of tire, the example of thumbpin again, example of the fork, and third one, the heel. Yes, heel, one more example. Let's suppose if we are walking on the beach, right? So we used to wear a flat slipper, right? Not the heel. Let's suppose if someone is wearing a heel and he or she, only she wants to, let's suppose, walk onto that the beach side. So heel will sink into the sand, right? Because the pressure is greater, because your surface area is very short. This heel will easily sink into the sand, if we are taking the example of the beach, right? So that's why we usually wear a flat slippers on the seaside or on the beach, because to decrease the pressure, right? Otherwise, if we are wearing these pointed shoes, so it means that your shoes or your heel is going to be sink in your uh, that sandy area or that sandy surface, right? In the football ground, you see that for grip or for a strong support on the ground, we use that pointed shoes for the football or for cricket or any other sport, right? Because we need a grip on the ground. So those pointed spikes uh, at the bottom of your shoes will help you to make a strong grip for with the help of greater pressure, right? If we are using the flat shoes on the ground field, so that will easily skid or that will easily slip on the surface, because there are wet surface on the ground sometimes. So that's why we are using that spike shoes on the ground, so that will help you to make a great contact with the ground. Okay. And one more question in this, with the reference of this diagram, that let's suppose if you find out the greater pressure from the diagram, there will be the greater pressure. In which example did you find that pressure will be greater? You may also answer in the chat also. So that will give me a concept that
Wait, so what's the question?
question
What's the
is, if
question?
you need to find out the greatest pressure among all these four examples, so which example gives you the greatest pressure?
I think it's number two.
Number two. Okay.
Yeah, number two.
Number two. So all of you are okay with number two. So in number two, we are having a greatest pressure, right? So in example number two, we are getting a greater pressure, because we know there is an example of a thumb pin, and thumb pin can easily penetrate. So there will be a greater pressure. And let's suppose if you want to write a short reason just to remember after the class. So that is a short area, and short area will give you greater value of pressure. And if we want to find out the lowest pressure, so then which example you choose?
I think it would be the car wheel
The
E?
because it has the greatest surface area.
Okay. So A is your answer.
Maybe the heel, because we have to also keep the force into consideration, right? So
Okay.
a car's mass is a lot compared to like a girl's mass.
Okay. So that also a valid point. But if actually this picture is taken from the past paper question, and the question is the same, that they are asking about the greatest, because in the lowest we need to also check about the forces, right? But again, the same concept for heel, because of that pointed area, because force is actually divided into two different parts, right? One is at the point of the heel, and second one on the foot or the front part of that foot. So that's why we can say that the lowest pressure will be on the tire. Okay. Because there are no values given, for just time being we just compare these. So in this example, so the wheel of the car gives you the lowest pressure. I hope it is clear, no confusion till now. Okay. Any question, any confusion
No, sir,
till
no
the basic
confusion.
concept? Okay, so it is clear. So now moving towards the next concept, because this is only related to the journal configurations. Now let's suppose if we want to know about the values. So let's suppose if we having two different concepts, two different examples with two different diagrams, right?
Wait, so can you go up for a second? I just want to copy the examples.
Okay, you may take the screenshot and I will also share the PDF file in the group, right?
Table 4. Oh, yeah, well, last one.
Okay. So
Uh,
let's suppose there is a concept of area. So we know that force is like mostly time it was given in the question. Otherwise, we can derive from other equations. So let's suppose if we talk about area, because sometimes they only give you the concept or any block or any diagram, and they ask you to just find out the pressure by yourself. All dimensions of the block are given. Done.
yes, sir, done.
O- So now we have two different questions, right? Question one and question two. And in both question you can see that weight is also the quantity or gives you the quantity of force. So actually force is given as 24 newton, 24 newton, both block, because both blocks are same, only the orientation on the ground are different, right? So what we need to do, we need to do to find out the pressure, right? So you need to find out the pressure, question number one, and also in pressure in question number two. Because you know that in this diagram there are three dimensions given in the question, right? But you know that we need to follow the area, that area is in contact with
Of the
the.
highlighted.
Yes.
Yeah.
So that highlighted area actually is for the reference, that that highlighted area is in contact with the ground. But in your exam, they will give you a blank block or blank diagram. You need to find out, because sometime question will be like this, there will be a block and they just ask you that in which dimension or by using which sides or by using which side with the contact with the ground, you will get the greatest pressure or the least pressure, right? I will also show you the questions from your papers. But let's suppose if we want to find out in question number one, so we know that we make area from these two quantities. So your area will be equal to 6 meters square, right? 3 into 2. So that will make area, two dimension makes the area of the block. And the second thing, the pressure, sorry, the force. So this will be the force. Okay. So just find out the value of the pressure.
Done, sir.
Okay. And
Done,
also,
sir.
okay, very good. And also find out the pressure from the second.
Done.
Okay. So what you observe that the pressure in the second diagram is less than the first one, right? Okay. Because your answer
Yes.
of pressure in question number two is less than question number one. Because what is the concept? The concept of area. Because weight of both blocks are same. So now the pressure actually depends upon the area or the contact area with the ground. Because in this diagram, area will be equal to 12 meters square, right? And force remains same. Okay. So this is the concept of basic pressure. That pressure we apply on objects in normal, we can say that on solids, right? Because till now we are only talking about the solids. So any confusion till now? Because you just need to use basic formula. The concept of area or the different orientation is in front of you. You just need to choose that area that is in the contact with the ground. And let's suppose if they ask you about the greatest pressure. So let's suppose if they ask you about the greatest pressure, so you know that for greatest pressure, you need to choose the less value of area, right? Shorter area will give you, because force is constant in both diagrams, right? So we need to choose the shortest area. So shortest area will give you the greatest pressure. Okay. Any confusion?
So the answer is question number one for the greatest pressure.
Okay. So you can just simply calculate the answers. The purpose of these diagrams to show you that how we just figure out the area by ourselves in the exams, because sometimes they just give you the blank diagrams and you need to find out area by yourself. SI unit, pascals.
Sir, in the exam, if we write Newton over meter squared, is that correct?
It is also accepted, but it is better to write pascals, because in your answer scheme sometimes they used to write Newton per meter square or pascals, but sometimes they
Okay,
only mention pascals, so it is better to go
okay,
with pascals, right?
all right.
So 2 pascals, because just like the recently the result for the A levels, students are very much confused with their grades, because threshold is,
Yeah, so
yes,
it's
so
different it's different from one country to another, right? The
y-
threshold.
because students are getting low marks, so why threshold is so much high? So that is the problem. So it actually happens sometimes, so don't take any risk, just go with the best option. Okay, so now that was only related with the solid, right? Let's suppose if we want to talk about the liquids. So in liquids, we are having a different scenario, right? Because we are going to talk about with the reference of height. Because normally we used to store water in the tanks or in a small storage tanks which are placed at the height or on the roof of the house, right? So that is related to the height also. Let's suppose if we consider this diagram on the right hand side. So what you observe that there are three different openings, right? And water is just flowing, or water just cover a longer distance at point number one. Let's suppose this is opening one, two, right? So at opening number one, water is actually covering a long distance. Okay. And at point number three, water actually covers a very short distance, right? So now we need to talk about and we need to know about this concept, that how pressure actually acts in the liquid. And I also gives you the reference of that name of scientist, that Pascal. So Pascal's law gives you the concept that whenever we apply pressure on liquid, right? Let's suppose if we fill just water in any container like this, so pressure will equally transmit in all directions, right? You can see that water is coming out equally from all direction, because all the openings, all the holes are at the same level. So water is coming out equally from all the sides. So that is the basic law of Pascal's that helps you to drive the equation for hydraulic lift and hydraulic brake. But that was not included, so we are not going to write that one, right? We are only going to talk about liquid pressure. So next concept is liquid pressure. Okay, in liquid pressure, now it is very clear that we need to take the reference of height also, right? Because height is very much important, because it is clearly mentioned in diagram number one on right hand side. So actually the very first important point that we observe from these diagrams, that pressure in liquid actually increases or decreases, we can say, with the depth or with the height, right? So the very first point, pressure in a liquid Pressure in a liquid increases with depth. And this topic is very much important because you observe that when we are swimming, let's suppose if someone of you know about the swimming and he or she wants to go into the depth of the swimming pool. So in the depth of the swimming pool, a pressure of the water or pressure on our body will increase, right? Because we are moving in the depth, so pressure will increase or on our body, right? So that give you the concept in diagram number one. At the depth, pressure is the highest value, right? As compared to point number three, where depth is very much low, because we just compare or we just find out the depth from the top surface to the bottom, like this. Okay, so this gives you the concept of depth. Pressure in a liquid increases with depth. The more you go into the depth, the greater the pressure on the body will apply, right? And one more thing that we observe from diagram number uh, 2 or 1 on left hand side, that is the Pascal's law statement. Basically, pressure at one depth acts equally in all direction. And one more interesting question, did you know about that Mission Impossible movie, the Tom Cruise? I hope all
Sir,
of
I was
you.
going to watch it. I saw it yesterday, like on Netflix. It was on my screen. I was going to watch it, but then I
Okay,
went and saw another one.
okay, if any one of you, or I hope that most of you know about that scene, that when Tom Cruise is actually climbing on that the tallest building in Dubai with the help of
No, I
that
don't.
suction cap. So actually, that is
Oh yeah,
all.
people do that. People do that.
Yes,
Yeah, I know.
yes. So actually, that is also a practical application of pressure. We will also going to discuss that one in the next class, because that actually with the reference of the atmospheric pressure. So that actually is practically possible. It is not like the fiction. It is also practically possible in our daily life also, right? So we will also going to discuss that theory, that how it is possible. So pressure at one depth acts equally in all direction. So this second point is a reference from the Pascal's law. Again, we are not writing the name because that is not our part of syllabus. So these are two important point from your diagram, right? And we can easily identify now the height or the other thing. Now the third most important point
Wait,
is
sir, can you explain why the pressure increases as the depth increases?
because whenever we are going into the depth, so you can observe that more molecules of water are on your upper surface, right? Because when we are on the top level of the water, right, so molecules of the water are at bottom. So the more you are going into the depth, so more molecules of liquid are going to apply force on your body, right? Because
Uh-huh.
when your depth is increasing, like if you take this reference, so you can see that now more number of molecules are actually applying force on your body as compared to the previous levels, right? Just like if you take a ball and just like a football, and when you try to immerse that ball into the water, right? So
Yeah, it just floats
initially
back
it
up.
was, yes, initially it was floating, and when you forcefully try to immerse that ball into the water, so you observe that water is actually applying the opposite force, right? So water molecules also apply the force, so that's why when we are moving into the depth, so force on our body actually increases, right? So that is the reference. And the third point is pressure in liquid also depends on the density. So these are three important points, and by combining all these 3 points, we are having a simple formula for pressure in liquid, and that is very much important because most of the questions are related to this concept, and the formula is pressure in liquid is equals to density. I hope you remember that symbol for density, right? That inclined P type shape.
Yes,
Acceleration
sir.
due to gravity, because gravity is very much important because that pulls that molecule in downward direction. So then they are able to apply force on your body. And the third one is the depth. So this is equation number 1, and this is your formula for pressure in liquid. Very simple formula. It means that pressure is actually depending upon all these three factors, right? If you increase the density, okay, I will write the name of these symbols. This is for density. Those who already completed that chapter know about the symbol. This is acceleration due to gravity or gravitational pull. You can also write that. Last one is the depth. So all factors are directly proportional. It means if you increase the density, pressure in liquid will increase. If you increase the gravitational pull, your pressure in liquid will increase. If you increase the depth, so your pressure will automatically increase because all are directly to the pressure. Pressure is directly to density. It is directly to gravitational pull, directly to the depth, right? But we know that if we are taking experiment on Earth's surface, so gravity remains same, and density remains same, because if we are using a water, so water is a liquid and the density of liquid remains same, right? If we change the liquid, so then density will be differ from the previous one. So this is the concept of pressure in liquid and pressure on solid. Any confusion till now?